Hello everyone. So till now we done the static route, default route. Manually we are configuring. If anything go wrong, it will not come up. Okay. Let me show you. Imagine. Let me take my blackboard. I will take this pencil and this color. Any color we can take. Imagine I have one route here. Let me take. I have router R1 here. I have another router R2 here. Okay, we have two router here and we connected with the cable, and we have some LAN network here. Imagine this is a LAN network 1.1.1.1, and here I have 1.1.1.2, and in between this one we are using 192.168.1.1 11 or 1.1. Here is 192.168.1.2, and imagine we have one more router here. Let me draw here. I imagine if we have one more router here, this router is having the route, he is having another route like 1.1. This one, let me write 2.2.2.2. So this router is also having the route for 2.2.2. This router, okay. R2 is having the same route what we are getting. Let me write this R3. R3 having the same route what we are getting from the R2. So this router, if we configure here in the R1, if anyone want to go to this 2.2.2, forward the traffic to this interface. Like this is a F0 by 0, and here also F0 by 0. Here is F0 by 1, here is F0 by 0, here is F0 by 1. So manually, what I done here, manually I configure. I am saying that router R1, if anyone want to go to here to this network, forward the traffic to this IP. Imagine this interface go down, but I have the same network here. So this router will not send the traffic. If anyone want to go to this 2.2.2, he will not forward the traffic this way, because this router don't know anything. We tell to router, if anyone want to go to 2.2.2, forward from this side, forward from this router to this router like this, and this will forward here. But this network now down. But the problem here, we have here, automatically it should update, so the traffic will not go here and drop here. It should go here immediately. But it is not happening. Why? Because this entry is not present inside my routing table. We have manual entry. We done manually. We are saying that if anyone want to go to 2.2.2.2, just forward the traffic to 192.168.1.2. We are saying we configure this way in the R1. So we have the issue. We have this issue. To overcome these types of issue, what we will do, we will use the dynamic routing protocol. So what dynamic routing protocol is going to do that one? Dynamic routing protocol automatically, when this network go down, automatically he will make this entry in the routing table. No one need to do any configuration. Automatically that entry is going to store in this routing table here, automatically store. This entry will remove and this entry will store. So our packets automatically go. No need to go manually telnet SSH this router and remove this route and enter this route. No need to do manually. Automatically this will happen with the help of dynamic routing protocol. So what we can say, dynamic routing protocol, we have different types of dynamic routing protocol. We have the RIP version 1, RIP version 2. We have the IS. We don't have this in our syllabus. IS. We have the OSPF. We have the EIGRP, and we have the BGP. BGP is used for external purpose, exterior gateway protocol we are calling, and these all are interior gateway protocol. Means we are going to use this all protocol inside the organization. This one When we want to advertise any server to the internet, we will use the BGP, and we can use BGP internal also, depending upon the company. This is the high CPU is going to utilize when we run the BGP. So that's why depending upon the company router hardware, we can use this one. Mostly many organization is using the OSPF as a interior gateway protocol. Exterior gateway protocol, we have only one, that is a BGP. So we have in our syllabus OSPF, EIGRP, BGP. So these three protocol we are going to learn, but before going to that one, we will learn this basic. No more we are using this RIP version 1. We are using RIP version 2 somewhere if you have a small router. But if you working in the telecom field, microwave, in the microwave we are using the RIP version 2. RIP version 2. In the microwave we have the indoor unit, INU. In that one we configure the RIP version 2 so they can exchange the network. Anyhow, we will see that one. So what I told, routing protocol automatically is going to update. Okay, dynamic routing protocol, when we use, automatically route will update. If any route go down, automatically whatever is the best route they will calculate, they will add in the routing table, they will remove the route which is down. And just now, as we told, we have the different types of routing protocol: interior gateway protocol, exterior gateway protocol. Interior means inside the organization we are going to use, exterior means outside the company, outside the organization, and BGP is only one routing protocol which is used as a exterior gateway protocol. And then again, interior gateway protocol also divided into two types: distance vector routing protocol, link state routing protocol. Distance vector routing protocol and link state routing protocol. So distance vector routing protocol work on the Bellman-Ford algorithm, and distance vector routing protocol periodically update. It is a classful routing protocol. In this one they are going to exchange the complete routing table, full routing table, and they will do the broadcast. Example is RIP version 1 and RIP version 2, whereas link state routing protocol is developed by Dijkstra algorithm. It work on the Dijkstra algorithm, and it will update only the link state, and it is a classless. Classless means, here if you see, this is a classful, means here if you want to use as a this routing protocol, that is a distance vector routing protocol, that is a RIP 1, RIP 2, we cannot use the IP which is having the subnetting done for that IP. Without subnetting only we can do this one, but here classless means it support to subnetting. In simple, you need to remember, link state routing protocol support the subnetting, and whereas distance vector routing protocol did not support the subnetting. And after that, what we can say, here whenever we are using the link state routing protocol, it will exchange only the missing route, whereas it is exchanging whole complete routing table, and it will update through multicast. Here they will update through broadcast. And here is example OSPF and ISIS. So our main topic will be OSPF. If you see in our syllabus, we have the OSPF and EIGRP, this one. Compare the routing concept of EIGRP, OSPF and BGP. This is the main thing we need to discuss. So now we are coming little closer to our main topic from the basic. So we have the metric. Metric is nothing but, it is what we can say, routing protocol is having different metric to calculate, to check. Whoever is having the best metric, that route is having inside the routing table. First what they will do, they have the AD value. Whoever is having the low AD value, that routing protocol is going to use. In the example, I have one router here, one router here. I configure two routing protocol is working in this network. So whose routing protocol is having low AD value, that routing protocol will be active, and other routing protocol will be as a backup. And in that routing protocol also, if same destination, if we have two route, they will check the metric. Whose metric is best, they are going to prefer that route in the routing table. So different routing protocol calculate the metric differently depending upon the different parameter. Like OSPF use the cost as a metric, EIGRP use the bandwidth and delay, RIP is used as a hop count. So we are going to see that one. Example, static root used as a administrative distance as a metric, OSPF used as a cost as a metric, RIP is used as a hop count, EIGRP used as bandwidth and delay, BGP used as a path count. So now just you need to remember, metric is depend upon the protocol, whichever protocol we are using. Depending upon that protocol, we have different thing to look the metric. Why we need metric? Because if you want to go to same destination, if you want to go somewhere, you have two route to go that one. So that routing protocol will check the metric for that two path. Which path is having the low metric, he will prefer that in our routing table. Okay, and in the what we can say, RIP is having the hop count, means RIP, when we configure the RIP is going to calculate the how many number of router is getting in between the source to destination. Wherever we have the less number of router, he is going to prefer that path, RIP. So OSPF is using as a cause. We are going to look when we do the OSPF, and EIGRP is using the bandwidth and delay. So this is a matrix we are going to look when we discuss the routing protocol in detail. So now we will go for the RIP. We have RIP version 1, RIP version 2, but we don't have in our syllabus. But it is good if you have this idea, so we can have the basic concept, then we can go for the OSPF. So RIP version 1 and RIP version 2, we have two routing protocol. This is a dynamic routing protocol. This is a open standard. It support classful. Classful means subnetting will not support, and they will do broadcast. Broadcast means they will forward the traffic to all the network, even if you are interested or not interested. And maximum we can use only for the 15 router. If you have more than 15 router, we cannot configure the RIP1. AD value for the RIP1 is 120, and it is used in the small network, and every 30 seconds they are going to exchange the routing table. That is, we can say the update time is 30 seconds, invalid time is 180 seconds, and flash time is 240. Means every 30 seconds they will update, and the other guy will not send within 180 seconds. He will say invalid time, and after 240 seconds they will remove that entry from the routing table in the RIP version 1. And how we can configure RIP version 1? We can configure, we need to write the router and the RIP, and then we will write the network and the network ID. This is a syntax to configure the RIP version 1. Okay, this is a RIP version 1. Example, this is a basic scenario. We can configure the RIP version. How we will configure? We will take two router, we will assign the IP address, and we have some LAN network. They are unable to communicate, so we need to configure the RIP. So how we will configure? First, same thing, enable config t host name and assign the IP address to the interface, whatever interface we have. Then after that we will write router RIP and network, whatever network you want to advertise. Example, this is a network. We need to calculate the network ID and write here network ID. That's all. Same thing we need to do in other router also. We will do this lab, so you will have the idea. Same thing we need to do for our network, whatever network you have. So this way we have the RIP. Anyhow, we will do one basic lab. So let me take the packet tracer. We can do in packet tracer, or we can do in the GNS also. Or if you want, I will do in GNS. Let me do this in GNS. So what we will do, I will take the GNS is off, or I open, or let me do in the EVNG. I already opened the EVNG, so let me create the new lab. Here what I will do, I will write RIP. Okay, RIP version 1. RIP version 1 I am doing. So what issue I have? Unauthorized. So maybe I have log out, or let me log in again, because from long time I log out. So now let me create one lab. Okay, so I will write here RIP version 1, and I will say save. So this is the dashboard. Now I will take two router. I will take two router. I can take any router. I will take these two. Number of router is 2. I will give name as a R. Okay, and here the symbol photo is okay, no problem. Whatever the default value, I will keep same like that, and I will keep one router here. I will keep one router here, and then I will connect this router to this router. And if you want, I can use the switch to use as a network. So which one? This one, switch. Here we will change the picture of the switch. This is a switch picture, and this one we can write SW. And how many switch I need? I need 2 switch, and all remain same. So I will take this switch here, I will connect the switch to this PC. Okay, let me increase the port in the router. We don't have port. How we can increase the port? Edit and go here and select here this one. Okay, I will select here also, edit and go here, and here this empty we will select the port and say save, and then we will connect this here. Okay, and then this one also we will connect here. Okay, and now I can take PC. I can say VPC, virtual PC, this one VPC, or if you want window we can use window, but it will consume 4 GB RAM. So better we use this because we need only basic lab. So I will take 2 PC, I will give the name as a PC here, and what I can do, I can change the image. Whatever image you want to take, you can take. So this is a 2 PC, I will connect this PC here, and I will connect the one more PC here. Okay, we are doing the RIP version 1 here, lab RIP version 1. So let me start the router. This one also I will start, 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 and this one also we will start, this one also we will start. We can connect the PC direct to router also, no need to use switch also. If you have low RAM, don't use the switch, direct connect your PC to the router, or you can do this lab in the packet tracer also. Okay, RIP version 1. This is a basic lab you can do in packet tracer also. If you have low RAM, do this lab in the packet tracer. So now I will keep this as this is a title. We are doing this RIP version 1, and here IP schema I can define here. This is same thing as we do 192.168.12.0/24. So this side will be .1, this side will be .2, and let me make duplicate. So here what IP we are going to use, I will write here. This side will be 192.168.1.1/24, and the other side will be here, this side will be 192.168.2.1/24. okay, so this side, this one, and here this IP, here we can give IP. I will create the IP schema here also. This one is we can create this as a 2, this machine, and here I will make this as a duplicate. We will give this one also here as a 2, this one also 2 here. Okay, so now let's do the configuration. We can write in notepad, or let me write, or we can do directly also. If you want, I can do directly also in the router itself. Let's do this basic configuration in router directly. So this one I will do here. First I will say no. Okay, and we need to wait. Let me start the another router also. I will start the other router. I will open other router. I will write no here also, and I will wait. This 2 router will start. Then meanwhile I will start this PC. I will give the IP to this PC IP, and we will write 192.168.1.2/24, and then 192.168.1.1. okay, so I am giving this is IP, subnet mask, and default gateway. Now we can check also. How we can check? We will write show IP. Okay, so everything is good. I will save this for PC1, and I will go for the other PC. This PC5 and PC6, they get taken the name anyhow, no problem. I will go here. I will write here IP 192.168.2.2/24, give space, and then we will write 192.168.2.1. this is the default gateway. Okay, and then we will check show IP, and we can save also 2.2 2.1. okay, this is okay. And now let's see our router is okay or not. This is a router. We can go here. We will start the configuration. We will write here host name. host name is R1, and then we will go for interface fast Ethernet 0 by 0. I will write here IP address 192.168.12.1 255.255.255.0, and then we will write no shut here. And the other interface, we have interface fast Ethernet 0 by 1. Okay, we have interface fast Ethernet 1 by 0. Here we will give IP address 192.168.1.1 255.255.255.0, and then same no shut. This is the two interface here. And now we have two interface. We can check show IP interface brief. So we have two interface, it is up. So now we need to do the routing protocol. So I will write router RIP, okay, and then network and network ID. We have two network. One is this interface and another is this interface. So these two interface I need to advertise. I need to activate the RIP in that two interface. So I will write the network ID. Okay, I will write the network ID. We are getting the simplex mismatch because switch is having maybe full duplex, he is having half duplex. I can change this one. So before changing, let me configure the routing protocol. So network, we will write 192.168.1.0. This is one network. Another network is network 192.168.12.0. Okay, this is two command we put here. And if you want to check, we can check here. Show IP root, show IP RIP, show IP because still we did not configure other side, that's why it is not coming. But anyhow, let me correct that interface, this duplex issue. I will go interface fast Ethernet 0 by 0. I will write here duplex R2. R2 is working here, R2 is not working, so I will write full. Okay, and I will go to another interface fast Ethernet 1 by 0. I will write here duplex full. Okay, now what I done, I just put duplex full because switch is having full duplex, so router is having half duplex, so we have duplex mismatch. If you see here what we are getting, duplex mismatch, switch is having the full duplex but router is not having the full duplex. That's why we have some issue here. So now I done router interface as a full duplex, so we will not have any issue. We configure in the R1 now. So now I will go to the R2. In the R2 we will first of all, let me enable, go here config T, we will write the host name as a R2 here, and then we will assign the IP interface fast Ethernet 0 by 0, and then we will give the IP address. We will write 192.168.12.2 255.255.255.0, and we will write no shut here. Okay, and then what we can do, here also we have the duplex issue, so I will write here duplex full. Okay, this one I wrote duplex full. Then I will go to another interface fast Ethernet 1 by 0. I will write here duplex full, no shut, and then I will assign the IP address. What is the IP? 192.168. Let me write again 192.168.2.1 255.255.255.0, and we will write no shut here. So already we have interface show IP interface brief. So if you see, interface is up. We can go in the global configuration mode, write router RIP network. What is the network? 192.168.2.0. One network, this one. Another network is 12.0. This way we configure the RIP. If you have confusion, let me write here in the notepad what I done here. See here, RIP basic lab. Okay, I will write here, maybe you will have some confusion, so let me write here enable config T host name R1, and then we write interface fast Ethernet 0 by 0, and we write here IP address 192.168.12.1 255.255.255.0. then we write no shut here. Okay, and I will copy the same thing, I will paste here. This one is a one dot, this one, and here is this like this. Okay, this is for R1. I will copy and paste, and I will divide this page. I will put here. This is R2, and this should be 2, and this should be 2, and here we will write router RIP network. What is the network ID? 192.168.1.0, and then we have network 192.168.12.0. okay, same configuration we will copy here also in this one, and he will change here. This should be 2.0. network ID, this interface network ID we need to write. This interface network ID. How we calculate network ID? This is network, this is network, this is network, this is host. Host we will make as a 0. So this is the configuration. And if you see here show IP route, we have the route. Okay, when we write here show IP route, if you see, this is the route R. This we get from the RIP. What we are getting, I am here in the R2, so here we are getting, if anyone want to go to 192.168.1.0, okay, they can forward the traffic to this 12.1 this site. Here we are getting the AD value. RIP is having 120 as AD value, and how many router is coming. If we want to go from here to here, only one router, so this is a metric is 1. Metric is 1 because number of hop count. RIP is using metric hop count, so only one router we have here, so that's why metric is 1, and via this one, and this much time we have this link come up, means RIP is having the neighbor from this much time, and this is a leaving interface. Okay, if you want to short this one, example, if you have more entry, if you want to short, you can short like this way, so you can check only the RIP entry. So this way we have the RIP entry. Now this guy can communicate with another guy. Example, the PC5 can communicate with the PC6. What is the PC6 IP? 192.168.2.2, I think. So reply is coming. PC1 1.1 1.2 is communicating with the PC 2.2. Both are communicating now. Okay, both are communicating, everything is working here. So RIP is successfully done here. Okay, so what we learn here, how we can configure the RIP version 1. We configure RIP version 1. So we need to assign the IP first, then we need to write the router RIP, after that network, and network ID you need to give, whatever network ID. We need to advertise this interface, so we need to calculate the network ID of this one and write here, and if you want to advertise this one also in the RIP, calculate the network ID and write here. This way we will configure, and if you see both PCs are communicating, and if you want to check here, you have the route here in this one, and if you want to check in the R1 also, you will have the route here also. Again we have the duplex issue, so maybe we need to put as a half switch. Let me open the switch and check what is the interface switch is having, which one. This is a switch. Okay, let me check. Show interface E0 by 1. Maybe if you see E0 by 1, what is the status of the interface? Interface is having full duplex. Okay, switch is having full duplex, so we configure full duplex, so we should not have the issue here. The issue which again it is showing here in the EVNG, it is showing here. Again it is showing half duplex. I think we configure as a full duplex. We did not configure full duplex. Let me, okay, this is we are getting from the R2 Ethernet F0 by 0. Maybe in the R2 we did not configure, that's why we are getting R2. I will go to the interface fast Ethernet 0 by 0. Interface fast Ethernet 0 by 0. I will write duplex full. Okay, and I will save the configuration. Show interface fast Ethernet 0 by 0, and we can check here duplex is full. and if we check for the other interface, R1 interface, show interface, fast Ethernet 0/0, it is also full. So now we should not have any error. Okay, so what we learn, we will check here routing table, show IP route. So we have the RIP. How we know this is a RIP? So let me make big this here, this R is RIP. Okay, so we can say this route learn from the RIP. And if you want to do short, this one, show IP route, and then you can write RIP. So it will be the short route. So this is a basic configuration about the RIP. We configure the RIP. Okay, so let